Welcome to Vulcan Materials Kennesaw plant. Sensile Technologies will be installing two wireless tank monitor systems for our primary diesel tanks. This brief tutorial will demonstrate the installation process and components involved. All components for installation can be carried within a small tool bag. Whenever doing an installation on top of a tank, a fall arrest harness is required, no matter the height of the tank. In this installation, we are able to gain access to the tank through an exiting breather tube. This is the preferred method for entry because it does not require tank modifications. This particular tank has a precipitation reservoir and a dirt and bug screen. To install the probe, we will remove the cap and create a hole just large enough for our cable to fit inside. Once the cap is prepared, we can then measure the external height of the tank, including the length of the breather tube, so we can cut the excess cable. After the cable is measured and cut, we will then lower it into the tank until it hits the bottom. At this time, we actually raise the cable just slightly off the bottom to avoid contact with any sludge or buildup at the bottom of the tank. Once the probe is secured inside the breather, we will prepare the wiring by trimming the excess and installing wire ferrules in order to maintain clean contact with the wiring harness. Now that the wiring is prepared, we will run it back through the opening that was created inside of the breather cap. We follow two primary rules when performing an installation on top of a tank. Number 1, don't fall off the tank. Number 2, do not drop the cable inside of the tank. In order to ensure that the probe does not fall down the breather tube and into the tank, we will zip tie the cable to the breather pipe during the final stage of installation. The pressure sensor is then run through the bottom of the monitor housing and secured. We now install a second sensor inside of the monitor housing. The sensor is used to measure the atmospheric pressure. The basic principle behind this measurement technique is called differential pressure measurement. The pressure sensor inside of the tank measures the pressure of the fluid, which increases and decreases depending on the volume. The monitor is designed to detect the difference between the fluid pressure and atmospheric pressure. Once the tank has been calibrated, volume and height can be calculated using dimensions and specific gravity of the fluid. Now that we have the probes installed inside the housing, we can connect them to the monitor with a wiring harness. We begin a testing process to ensure proper and secure connection of the harness and signal connection with the network. During the installation, the unit is communicating with the server so that it can begin calibrating the tank. The excess cable is fastened to the breather tube with zip ties. We then create what is called a service loop in the cable so that no water can run up the cable and possibly into the unit. The loops are secured and the monitor is strapped to the breather metallic band straps so that a neat and tidy installation is complete. A closer look at the units shows that there are two T20 star screws on each side to tighten and loosen the monitor and housing. Inside the unit is a dual lithium battery pack with a quick release tab designed for quick and easy replacement changes. The SIM card is mounted on the back of the unit board, which is held in place by potting resin. The monitor, developed by Sensile Technologies, is called Netris.